Okay, this is lesson 3.2 Residuals and Coefficient of Determination. We are continuing in chapter 3, working with our least squares regression. Today we're going to talk about a residual plot. And what does it tell us about the set of data? So let's start with the coefficient of determination. A lot of you have already looked at your linear regression in your calculator, and it calculates r squared for you. And what is r squared? Well, r squared is the coefficient of determination. It is the fraction or percent of the variation in the values of y that can be explained by the linear relationship with x. So we use it as a measure of success as to how well the data can be explained in a linear relationship. A residual, remember, is the difference between the observed value and the response variable and the value predicted. So it's the difference between vertically. So we're talking about the difference between my y value, my actual y value that was observed, and my y hat value predicted by our least squares regression line. So it's the difference between my observed. I take my observed and I subtract the predicted from the least squares regression line. Okay? So the mean of the residuals is always 0 because the sum of the residuals is always 0. When we construct a residual plot, we of course put the x on the horizontal axis and the residuals are on the vertical axis. So we keep the x values of our data and we plot the residuals of those x values on as our new y values for a residual plot. If a pattern emerges, then linear is not a good fit for the data. So that's what we're looking for when we plot a residual plot. We're trying to determine how good a linear regression model is for our data. How well does it model it? The standard deviation of the residuals is the approximate size of a typical or average prediction error, or the approximate size of a residual. So we are looking at the average distance of the actual values from the least squares regression line, or the average distance of the actual values from their expected values, and their expected values are what's found on the line. The formula for the standard deviation of the residuals is we take the sum of the residuals squared. So we take the sum of each y value, subtract the expected y value and square it, and we divide it by n minus 2 and take the square root of that, and that gives us the standard deviation of the residuals. Extrapolation. This is when you use a regression line to predict outside of the range of values of the explanatory variable, and this is not something that you want to do because you're talking about something that's outside of what your model predicts or can necessarily predict accurately. So you have to be careful when you get to outside of your range of values of your explanatory variable, because it's not going to be something that necessarily matches your regression that you have created. Okay. Exercise 9, this is talking about exercise 9 on page 159. And this is where I'm going to leave you with your assignment for before you come to class tomorrow. You need to turn to page 159 in your book, and you have a chart for number 9 about speed in kilometers per hour and fuel used in liters per 100 kilometers. You need to program the speed values in your list 1 in your calculator, and you need to program the fuel used in liters per 100 kilometers in your list 2 in your calculator, and bring that to class tomorrow so that we can work on making a scatter plot, a least squares regression line on that plot, and a residual plot on top of that as well. And we will be interpreting all of those things together. So make sure you have that programmed in your calculator when you come to class tomorrow, and bring your book so that we can complete the 2 exercises that you have in your notes. Okay, that does it for today. See you tomorrow.